In this video, you'll be learning about how to construct a box plot, which is another way to display data, and unlike the stem and leaf graph, offers us some added advantages in terms of visualizing how compact the data is. Before we actually begin to talk about box plots, you should have actually watched an against all odds video that goes over the basic concept of it. So if you haven't watched that video yet, please be sure to do that. It will help make this even easier to understand. And then before we actually dive into box plots, the very first thing we have to do is take a look at a 5-number summary. So here's a list of ages of people that showed up to a concert, and even though there's only seven people at the concert, it's a pretty lame concert. I'm using this smaller data set to actually make it very convenient for you to see how the 5-number summary is developed. So there's an odd number of people at the concert. There's 7 people, and the 5-number summary is a statistical way to talk about the positions of the data and including the center. So the 5-number summary are made up of the minimum, first quartile, median, third quartile, and maximum. The minimum is easy enough to point out. It's the lowest one in the data set. The maximum is the highest number in the data set, 67. The median is the number that's in the middle of the data set. And since there's an odd number of pieces of data, the median would be 20, the number that's dead set in the middle. Now the median breaks up the list into 2 sections, the lower half and the upper half. So the first quartile is also nicknamed Q1. It represents the middle or the median of the lower section of the list. And if there are 3 numbers in the list, the middle of that lower part of the list is just 15. So Q1 would be 15. And likewise, the third quartile, also nicknamed Q3, would be the middle or the median of the upper half of the list. So 54 would be the upper quartile. We can take this information of the 5-number summary, and instead of listing it as 5 numbers, we can change that information into a graph. So that's what a box plot is all about. I generated this one right off of our graphing calculator app. The box plot shows the minimum, shows Q1 as a vertical bar, the lower quartile. It's a little bit difficult to see here, but this is shaded in. This is Q2, the median. It has the upper quartile here, as well as the maximum. Now, going back to just our last lesson, I believe, we were talking about giving a fantastic description of the data that you're seeing here in the box plot, or that you had in your list. And one way to summarize that is with one of the centers. The one that's the most convenient to grab is the median, because it's right here on the graph. So the median is 20. The range from the maximum to the minimum ended up being 55. So that's a measure of the spread. The data is actually skewed to the right, and one way to visualize that it is skewed to the right is to find the median, and then this often will work in terms of deciding how it's skewed. Find the median, and then look at the distance from the median to the minimum, and then look at the distance from the median to the maximum. And the longer the trip, the more that it's skewed to the left or to the right. So this one is skewed to the right because of that. The data is stretched out towards the right. Remember that each of these divisions here between the minimum and Q1, between Q1 and Q2, Q2 and Q3, and Q3 to Q4 represent each 25% of the data. So 25% of the data on our list are between these two values, 25% are between these two values, another 25% are between these two values, and the last 25% are here. So you can kind of think of it as like a football game where there's 4 quarters. After the first quarter, we already have this much data, so the data is really compressed in that zone right there. And then between the first quarter and halftime, or the median, the data is also pretty well compressed. But then from the median to Q3, the data is really spread out there. So the box plot gives us a way to get an impression of how compressed the data is. Let's take a look at another data set. I'm just going to add one more number to the list we already had. And I'll change up the meaning behind it. Instead of this being concert goers, let's say this is how many months someone has been in a relationship. So I just added on another number to our list, 300, which so happens to be my wife and I's anniversary is coming up, 25th anniversary. So we've been together or married for 300 months. And if we include that into the list, we can also work on a 5-number summary. Here it's going to be slightly different. If you take a look at the 5-number summary, you may want to pause the video and try to figure out how did I get those numbers there. So maybe give that a try. See if you can figure out how I generated those 5 numbers. If you've given it some thought, you can unpause the video, and here's the answer. So 12 is the minimum. The median, well, this has got an even number of pieces in the data set. There's actually 8 numbers. So the median, there's not a single number in the middle anymore, but the median would be halfway between 20 and 27. So the median would be 23.5, the average of the 2 numbers that are in the middle. I guess if you read ahead, you could actually have seen the answer here too. With an even number of entries, the median is the average of both middle numbers. And how did I generate Q1 and Q3? Well, again, it's written down below here too, which I guess I didn't notice. The lower half of the list is now these 4 numbers, and the Q1 would be the middle of the lower half of the list. So since there are 4 numbers in the lower half of the list, the median is shared between the 15 and the 19, so you need the average of those 2, which would come out to be 17. And likewise, the same thing happens for the upper half of the list. The median is the average of these 2 numbers. Now, this procedure of actually finding the 5-number summaries by hand is fine to know, but even with a graphing calculator or a cell phone, there are ways to calculate this by just typing in the data, and you'll see that shortly. So if this is going over your head or you think it's going too fast, calculating these things, the technology will help us. But it is important to see where these numbers are coming from and to keep in mind that we're trying to find these quarter marks. All right, so with that last example, I can take that data and also put it into a box plot. You can see the Q1, you can see the minimum, Q1, Q2, Q3, and then the maximum there at 300. And I've given a fantastic description right here. The median is 23.5. The range is now extended to 288. It is seriously skewed to the right because the median is here, and there's only a short trip there to the minimum. But from the median to the maximum, it's quite a long hike. So this is even more greatly skewed to the right as before. Since it's skewed to the right, where do you think the average would be? If the median is here, where do you think the average would be if it is skewed to the right? If you paid attention to the last video when it was describing what happens between the median and the mean when the graph is skewed, the mean would be pushed or pulled in the direction of the skew. So although this does not have the mean displayed, the average would definitely be to the right of 23.5. And then the last thing to write down is that 300 is likely an outlier. So with the Fantastic Four, there were 4 things to give, and the last thing is to state if there are any outliers. And I feel pretty confident knowing that that 300 just doesn't seem like it fits in with the rest of the data because it's so much bigger than the rest of them. So let's actually figure out. I suppose that it's an outlier, but how do we actually figure out if it actually is mathematically? So what does it take to be an outlier? Well, simply you have to be beyond the fences. And there's a four-step procedure to figure out where outliers might be. You can follow this procedure and or use the graphing calculator or a website to generate the fences and the information. I believe you do need to know for the tests and for the midterm at least how to figure out the outliers by hand. So you don't have to memorize the procedures actually. I believe on the formula sheet on the exam it actually gives you a brief reminder of how it's done. First thing is to calculate the interquartile range, also nicknamed IQR, which is the upper quartile minus the lower quartile. The IQR is a measure of spread. It is the length of the box, or the length of the middle 50% of the box and whisker graph. Once you have that number, the IQR, figure out the maximum whisker length. Also, I nickname that the MWL. The maximum whisker length is 1.5 times the IQR. Step 3 would be to calculate the lower and upper fence. And the lower fence is found by taking Q1 and subtracting away the maximum whisker length. The upper fence is found by taking Q3 and adding on the maximum whisker length. And those boundaries are called our fences. Anything below it will be an outlier. Anything above it will be an outlier. And that is the last step, is to report any numbers that are beyond these fences. All right, so for this example right here, we're going to actually calculate that. All right, well, it was going to work, but here we go. All right, so in figuring out the interquartile range, we have to actually have that the information from the previous slide. So let's actually go backwards. All right, so the first step is to figure out the IQR, which would be 60.5 minus 17. So 43.5 is the IQR. That's the end of the first step. Multiply by 1.5, and it tells me that my maximum whisker length is 65.25. The next step is to take Q1, which is 17, and take away 65.25. So my lower fence sits at negative 48.25. There's no relationship here that is below negative 48 months, so I know that there aren't any outliers to the left. Now I need to figure out the upper fence. So the upper fence is taking Q3, 60.5, and adding the maximum whisker length, which was 65.25. So the upper fence is 125.75. 125.75 for the upper fence. Any number above that would be an outlier. 67 is below it, 300 is certainly above it, so that's the official discovery that 300 is an outlier. And you should try to run through those calculations yourself, maybe before you actually begin the next assignment. All right, so then the last bit of information here to show you is what a modified box plot looks like. So again, I generated this off a graphing calculator app, and it is very similar to the box plot. The box plot would actually connect Q1 to the minimum and Q3 all the way to the maximum, We saw that a few slides ago. In this particular version of a box and whisker graph, this modified box plot will highlight any outliers. So the rule is that if there's an outlier, do not connect it to the whisker that's sticking out of each side of the box. Instead, that whisker is allowed to travel up to and including the upper fence, which was at 125.75. But since there isn't any data between 125.75 and the next highest number there, which was 67, yeah, 67. The whisker only extends up to 67. So what the modified box plot will do is it'll actually draw a person's attention to these outliers, and the outliers most often are pretty relevant in terms of its effect on statistics such as the range, the standard deviation, and as mentioned before, the average. So with doing all that by hand, the next thing that probably should be done is to give you a brief overview of how to do this on the graphing calculator. So let me just quit out of this. Okay, I just have to go there. Here we go. So how do we actually generate this on a graphing calculator or an app? So we're going to go to Stat, the Statistics button, and select Edit. And under list number 1, you're going to type in all the data that you want to use. You can see I already typed it in. And what I want to do is create a box and whisker graph with that data. So I'm going to press the second button and Y equals to bring up my statistical plots. And what I want to do is I want to turn the first plot on. So I would select the first plot, turning it from an X into a plus. Right now it's saying it's going to use list number 1, and it's going to create a box and whisker graph out of it. I'm going to click this icon here to show you that it brings up this wheel of different types of graphs that we will talk about in the course. But the one we're going to look for is just the box plot. It says it's going to make the mark of any outlier that exists a plus. Well, that's not going to apply here because there aren't any outliers in a box plot. We're going to use list number 1. I mean, you can change it to other lists if you like, and just leave the frequency at 1. You can change the color around if you like. So make it a green and click done. And hey, where's my graph? Okay, so you have to actually press the graph button to see it. Hey, where's my graph? I press graph. What gives? So right now you're in a standard viewing window from -10 to +10 for the domain, -10 to +10 for the range. If you go to the zoom option and select zoom stat, it's right there at the bottom, it'll actually snap that box and whisker graph right into your viewing window. So this is the same graph we had before. Notice there's room above it. If we wanted to graph other lists, like list 2, list 3, list 4, we could actually have them side by side with this one, and those would be an example of something called a parallel box plot, where you have multiple box plots for comparison's sake, one atop the other. So let me show you a couple more things. I'll click done at the very bottom and go back to second Y equals to show you that with the touch of a finger, you can change it from being a box plot to a modified box plot. Clicking done and clicking graph will actually produce the modified box plot for us. So although you may, yes, you will need to know how to calculate outliers by hand. You won't have to draw box and whisker graphs by hand. You can use the graphing calculator to help you with those in the course. Let's see. So is there anything else left to show you? Oh yeah. Well, how about one more thing? An important way to generate some statistics from a list that's actually typed in, like list number one, um, is to use the one var stat command. So if you have information typed into like list one here, we can press stat and then calculate. And it's the very first option, one var stats. Now, when you stop right there, if you clicked enter, it would actually give you all the information you needed. But what it's really waiting for is which list are you, do you want me to, the calculator is asking which list do you want me to generate the statistics from. If you just click enter, it is understood that the calculator will default and use list one automatically. So if we just hit enter, would be fine, but if you want to do it this way as well, you can press the second button and then number one, and that'll bring up list one after the parentheses. If you wanted to generate the statistics off of list two, you'd press second and then two. So I'm going to do that. So second, list one, close the parentheses, hit enter, and you can see that it's given me a bunch of valuable information. The 5-number summary, which we figured out by hand, is right here on the right side of the screen. And we've got some other information here that's very valuable as well. X bar, or some people call it X hat, is the average. The average is 64.25. The sum of all the x's is 514. So this other bits of information maybe not as valuable. SX is the standard deviation, which we'll be talking about. And then we also have 8 is the N, which is the number of pieces of data. There's 8. Let's maybe reference one last thing. Remember that in the box and whisker graph, we were talking about this graph being skewed to the right. And you can see how this agrees with the median and the average. The median is staying resistant at 23.5, while the mean has been non-resistant. It has been pulled towards the direction of the outlier, which is 300. Since the graph is skewed to the right, the average will be higher than the median. So that's a little walkthrough on box and whisker graphs. Again, if you need to watch the video multiple times, do that. You could actually find some information in your textbook on this if you want to read up on it. Or if you haven't watched the Against All Odds videos on stem plots and box and whisker graphs, those would also be very helpful. And remember, we're not going to go too fast, but this is just a routine of using the graphing calculator to get this information and make these graphs. So you're expected to dig in and do your very best at this. And we'll be practicing box plots real soon. So keep on doing the best you can, and we will see you either online or in person later.